All right, this is the second video for chapter 5. So we're going to do the perpetuity and we'll have some future value questions to solve here. So let me pull our sheet up. All right. First of all, what is a perpetuity? That means it goes on forever. Uh, it's something that, let me make sure I'm sharing it correctly. Yeah. It means that if you put money away, the cash flow is gonna be forever. In other words, instead of compound interest, which we take the amount of money we make and we put back into the investment and then we get interest the next period, a perpetuity means that every dollar I make, I pull out of it. So if you want to look at it this way, if I had $100 in my bank account and I wanted a perpetuity of 5%, that means I'm going to get $5 forever the life of that. So it's not finite like an annuity where it ends. Because what I'm doing is I'm just pulling out that money. So a couple of those things you want to think about is the cash flow. That's the $5. The interest is how much I'm making off it. And then the present value is how much money you have to put into the perpetuity in order to get the $5. So or you can look at it this way, is that a cash flow is equal to, so you want to think about it this way, cash flow is equal to the interest rate times the present value, right? $100 times zero point 0.5 would be the cash flow. Well, you could take that same equation, you could rearrange it. So if I want to find the, let's say instead of the cash flow, I want to find out how much money I have to have, the present value. Well, I would just divide it by the interest rate. It'd be the cash flow divided by the interest rate. So the cash flow divided by the interest rate would be the how much money I need in order to get that cash flow at that interest rate. So let's look at what we have here. We have a perpetuity. What we're solving here is present value. We're solving how much money do we need in our account in order to get 12% and a payment of 120,000. Now, this is important. I made this a little more difficult because perpetuities are pretty easy. Um, when you look at the PowerPoint, you can look at the equation. But I want it not every year. This is 12% interest. I want this every month. So I want 120,000 per month, right? However, that's an APR, that's an annual interest rate. So what we're going to do is I'm going to go equals. And again, so if we're trying to find the present value, how much money we need in our account, well, it's going to be the cash flow divided by the interest rate. Be the interest rate. That would be how much money I would need. Now that's going to be wrong, right? If I wanted 120,000 per year at 12%, it makes sense. I need $1 million. But remember, I want that per month. So what I have to do is I have to divide the interest rate. And you know what? That's not going to work because you know what you need to do? I need to bracket the interest rate divided by 12. So you have to bracket that. And that's very important because what we're doing here is I'm taking the interest rate per month. And that's going to be 12% divided by 12. So really what it is, it's 120,000 divided by, um, well, 12% divided by 12 is 1%. So what we need, this is what the question is stating, we need $12 million in our account today in order to get 120,000 per month if we have an APR 12%. Next, what we're trying to solve is the payment or the cash flow. We want to know the cash flow, how much we need. So we have an APR of 4%. Uh, I have $454 today. I'm putting into my account. Uh, I'm going to earn 4% off that. And I want to know what is my cash flow, not per year, every, hold on, every 6 months. That's what I want to know. Every 6 months, what is my cash flow going to be if I have 454,000 at a 4% interest rate? So all we do here is I'm going to go equals. Now we're solving for payment. Remember, payment is equal to the present value times the interest rate. So I'm going to take the present value, that's what we put in our account today, and then I'm going to multiply it. Now I'm going to bracket this because I need the interest rate per semi-annual every 6 months. So if we have $454 today, and this is going to go on forever, I'm going to pull my money out. There's no compound interest, and I get 4%, and I want it every 6 months. That means it's going to be $9.08 every 6 months. And I just want to show this. Now, this is going to be incorrect, but if I took out that divided by two, that's $18.16 per year, right? Makes sense. 4% of 454 is 18. And then the reason why we divide it by two is to get what is it per 6 months. Let's leave this question. These are questions how I will write it up. So if you have this question on the exam, I would recommend doing it this way, and hopefully this makes sense. You just deposited 5,000 in a bank account that pays 4% nominal interest rate. So let's put that in. 4%. Compounded quarterly. So first thing you want to do is, well, if it compounds quarterly, I want to know what is my interest rate per quarter. So I'm going to divide it by 4. Quarterly means we're doing payments every quarter, so it's 4 quarters in a year divided by 4. That's 1% per quarter. And then you multiply it times 4, that'd be the APR, the interest rate. So a 5,000 bank account that pays 4% interest rate compounded quarterly. If you also, so now what we're doing is we're going to add a cash flow of $5,000. Now, if you add another 5,000 to the account 1 year, 4 quarters from now. So let's do this really quick. I'm going to write the quarters down because it gets a little confusing with quarters. So I'm going to do quarters here. And what do you, Excel knows patterns. So I'm going to highlight 0, 1, 2. And if I drag this down, it's going to know I'm adding a 1. Just show you another technique that you could do if you just want to do quarters, make it quick. I can go the previous period and I can say plus 1. And that's always going to add 1. And then I could drag this down and hit Control D. Sorry. Control Z reverses it, and then we'll hit Control D. And then it's going to do the previous one plus 1. So you could be kind of creative with that. All right, so what is this saying here? We're going to add another 5,000. So we added it today at time 0 and then at quarter 4. Right? 4 quarters from now. That's another 5,000. That means we added 0 in these quarters. And the reason why I had to show it, we're adding 5,000 every year, it looks like. But the reason why I had to put those zeros there is because it's compounded quarterly. So we want to separate it. And then we see that we added another $5,000, or I'm sorry, 7,500, 8 quarters from now. That means the 5th quarter is 0, 6, 7. And then the 8th quarter, we added some money, 7,500. And then that means the rest of it, we didn't add any money. So we added at time 0 in the 4th quarter and the 8th quarter. How much will be in the account 3 years, 12 quarters from now? So we're trying to find the future value at time 12. So I recommend anytime you're doing future value, something like this, well, I got the quarters, but I want you to think about if we're finding out what that 5,000 is worth 3 years from now, it's going to compound in 12 quarters, right? We want to know what that's value in 12. So what I'm going to do is this is the quantity till the future value, or the quarter to the, so we got 12 quarters to the future value, if that makes sense. And what I'm going to do is I'm going to do the same thing. Well, I'm going to go the previous minus 1, and I get hold down shift, drag it down, Control D. So that's real important because that 5,000 is going to compound 8 quarters. And then that 7,500 we're paying 8 quarters from now. That means if I want to know how much worth 12 quarters from now, that's going to compound for 4 quarters. So now what we do is find the future value of each cash flow. So I'm going to go equals. I'm going to go the future value is that cash flow times 1 plus the periodic interest rate is real important. And then I'm going to the power of, well, what quarter? The 12th quarter. It compounds for 12 quarters. So, and remember, you want, since we're compounding quarterly, you want the periodic interest rate. So I'll do the same here. Well, this is going to compound for 8 quarters. So I'm going to go that amount multiplied times 1 plus the interest rate to the 8 quarters. And then lastly, we'll do this one. 7,500 multiplied times 1 plus the periodic interest rate to the, well, how much does it compound? It'd be 4 quarters. So to find the answer to it, now we're just going to find the future value of all cash flows. I'm going to go equals. I go this one plus this one plus this one. Another technique you could have done, I could have say equals, I could hit sum, and all I have to do is highlight that because those are blank. It automatically knows that those are zeros. So you can just highlight. That's a pretty quick way of doing it. Question 2, this is very similar, but we have to read on. We want to know the future value of some amount. So after graduation, you plan to work for Dynamo Corporation for 12 years and then start your own business. You expect to save a deposit of $7,500 a year for each year for the first 6 years. So let's do that real quick. At time 1 through 6. So let's do our years. Well, we start at 0, 1. Oh, no, I'm gonna do the same thing. I'm gonna do that plus 1. So I'm doing the previous plus 1. That's a great equation. I'm gonna go all the way down. I'm just gonna drag that down. So we got our years. So we want to go, okay, the first cash flow is 7,500 starting next year at time 1. And that's going to go till 1 through 6. Then it says we do a 15,000 annually each year for the following 6 years. So at time 7, this gives it right there for us. Time 7 and time 12, we will have 15,000 we're saving. So I'm going to go to time 12. There's our cash flows. In addition, your grandfather just gave you 35,000 graduation gift, which you will deposit immediately. So that's today, the present value, 35,000. So what we want to do is we want to know how much will we have in 12 years from now? Well, it's compounding annual, so we don't have a more than one time a year. So it's not quarterly, it's not weekly or monthly. So that makes it a little more easy. You don't have to worry about it. And then what I would do here is we want to know, well, we want to know what all these cash flows are worth in the 12th year. So now I want to know how many years will it compound for. So that's going to be 12. And then I'm going to go reverse again. Remember, do this for future value. I'm going to go minus 1. This just shows how many years till the future value. Now, if we do it correct, we're going to do it one time, and I'm going to drag that equation down. So I want to find each one. So we're going to go equals is the future value equation. So we're going to say the present value or the cash flow at that time multiplied times 1 plus the interest rate. Now I'm going to drag that down, right? I don't want that frozen because I want, when I drag it down, I want to do that one. I want the interest rate frozen though, because I want it to, so I'm going to hit function F4. I want it to always have 9%. I don't want to drag that down, that interest rate. Then we're to the power of, and that's why we did this here, years to future value. That's going to compound for 12. I do not want that frozen or an absolute value or a fixed value. What I want is when I drag it down, I want this number to go against the 11 years. So if you did it correct, that 35,000 in 12 years at 9% will be 98,000. So I can drag that all the way down. And you'll know if you do it correct, if it lights up green, and it did. And you see the last payment of 15,000 is 15,000 because it's paid in the 12th year. It didn't have time to compound. I'm going to pick a random one here, and you can see how it's done. It was this cash flow multiplied times 1 plus the interest rate, did not drag down because we had dollar signs, to the power of, and that did drag down, of 4. So to answer this question is we're going to go, well, it's a sum of all future cash flows. So I get equals, I hit sum, tab, highlight it. That's how much it's worth in that time period. Here's a hard question. I love this question though. Your sister turned 35 today and she's planning to save 85,000 per year for retirement. With the first deposit to be made 1 year from today, she will invest in a mutual fund that's expected to provide a return of 7.5% per year. Let's plug that in real quick. If you're going to be a financial modeler or you always want to have an assumptions page and you want to label it. So if you read what is given to you by your management, you want to make sure you label, oh, this is the interest rate. You can do it in a separate sheet, but you want to make sure as you're reading it, you start labeling stuff off. Uh, she is planning to save 85,000 per year. So I'm going to put that there. That's amount saved per year. That's 85,000. Um, bu- 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 Now it says years to retirement. So we have the interest rate, 25 years after. So she got 30 years till retirement when she turns 65. And then she expects to live another 25 years to age 90. This is her goal for her finance. Under these assumptions, how much can she spend each year after she retires? Her first withdrawal will be made at the end of the year. So what we're trying to find is, well, she's going to save 85,000 per year at 7.5% per year for 30 years. After that point, we're going to have a certain dollar amount. How much will she have if she wants to take that money out? Um, how much can she take per year out if she does 85,000 for 30 years? For 25 years. So she's going to save it for 30, and how much will she have per year? All right, so let's plug that in. So we got 25 years retirement. We got all those numbers saved. So the next one is step one. Find the future value. How much money will she have in 30 years? So that's what's asking. And I believe I have to do a negative. I didn't correct it yet on this sheet, but follow me on this. So we're gonna do the future value. I want to know 85,000 per year. So first thing it's asking is the rate, comma, total number of payments. Well, it's 30 years that we're gonna do 85,000, comma. What is the payment amount? Well, it's 85,000, comma, what's the present value? That's zero. I don't think she saved any money today. It's just 85,000 per year. And then I'm going to hit comma, and I think this is going to be incorrect because I put that as a positive. That means the future value will be a negative. What I should have done was the amount we're saving should be a negative because we have to pay that amount. So I'm just going to put a negative outside of that future value. I just want to flip that value to a positive. That's all it is. That's just me, how I put it in Excel. But you want to understand why does Excel is assuming you're getting paid that 85, and that's why the future value is negative. When in reality, she was paying the 85,000 per year to an annuity, and then that future value of 8.7 million would be positive. Step two, find the PMT for retirement. Right? So in 30 years, she'll have now, let's assume we're in 30 years. She's 65. Now, what we're going to do is trying to find out what is the PMT for that time period. So you have to think about what that 8.7 represents. So I'm going to go 7.5 interest rate, the first thing, comma, total number of years, 25 for retirement, comma. Next one, what is the present value? Well, the present value is that retirement fund. So we should have put, and we're not saving any money after that period. We have 8.7 million in 30 years. That becomes the present value. That should have been a negative that we put in Excel. And we're gonna have to flip that sign again because I did not do it that way. And then I'm hit comma. Well, we're going to have zero future value because we are putting $8.7 million in 30 years, right? When she's 65, and we're expecting no more money left over. Now, if she wanted $10,000 left over, I would have put 10,000 for the future value. Then it would have corrected the PMT saying this is what you could take out in order to still have 10,000. But in this question, there is no money left over. She wants to have it all out of that retirement fund by age 90. So all we're gonna do is close it. Again, it's gonna be incorrect because of that negative sign. So I'm gonna put that out there. So let's read through the problem real quick. So if she saves 85,000 per year for 30 years at a 7.5% interest, in 30 years, she'll have 8.7 million. Then she retires and still earning 7.5% interest. That's important. Still during this time, she could take out 788,000 per year for 25 years. And then that annuity is done. Well, hopefully that was enlightening to your financial skills and your ability with Excel. So, any questions, please let me know.